Hello everyone. So this is a question from JEE Mains 2026 8th April Shift 2. Consider the following reactions in which all the reactants and products are present in the gaseous state. Okay, cool. So we have a reaction 2xy and forming x2 plus y2 reversible reaction. The equilibrium constant is given. xy plus half of z2 again reversible reaction forming xyz giving us the equilibrium constant is 5 into 10 power minus 3. The value of K3 for the equilibrium is, so this is the reaction for which we are supposed to calculate the equilibrium constant. Okay, and the chapters involved is equilibrium obviously. So to solve this question we would have to know few characteristics of the equilibrium constant. Okay, so let us say that we have the reaction, for example CH3COOH plus C2H5OH. So you can see the starting compound is an carboxylic acid and an alcohol, so obviously it is esterification. So we will get CH3COO C2H5 plus H2O, right? So let's say this is a general reaction that we have taken, and let us say that the equilibrium constant for this reaction is 4 at 25 degrees Celsius. Okay, so I have mentioned temperature because equilibrium constant is temperature sensitive, so that's why I have mentioned the temperature. First thing that we should know about equilibrium constant is that if a reaction is reversed, the value of the equilibrium constant is inversed. Okay, so I will write it down. If reaction is reversed, value of equilibrium constant is inversed. Okay, so for example we have taken this as an example. So if we write this reaction in inverse manner, that is, now this time the ester is reacting with water to give us the corresponding alcohol and the carboxylic acid, that is CH3COOH plus C2H5OH, right? So for this reaction the value of equilibrium constant, so let us say the equilibrium constant here was K, and let us say it is, for this reaction it is K dash. So you can see here the value of equilibrium constant is inverse. So if it was K, now it will become the inverse of K, that is K to the power minus 1 or 1 by K. So the equilibrium constant of this reversed reaction will be 1 by 4 at 25 degree Celsius. Okay, very important first characteristics. The second one is, in general, if an equation is multiplied by n. Okay, second characteristic of the equilibrium constant, if an equation is multiplied by n, the new equilibrium constant will be raised to the power n. Okay, the new equilibrium constant, so let us say the old one was K, so let us say the old one was K, so the new equilibrium constant will become K to the power n because we have multiplied by n. So the equilibrium constant will be raised to the power the number that you are multiplying the equation with. Okay, for example, so let us say we have an equation H2 plus I2 to HI. So let us say the equilibrium constant for this is K. Okay, and let's say we multiplied this equation by n. So this reaction will become NH2 plus NI2 is giving us 2NHI. Okay, so the equilibrium constant for this reaction will become K to the power n. So whatever was the old equilibrium constant, it will be raised to the power that we have multiplied the equation with. So that's why it became K to the power n. Okay, cool. This is the second characteristic. The third characteristic of the equilibrium constant is, if the equation having equilibrium constant K, if the equation having equilibrium constant K is written in two steps, and those two steps have equilibrium constant K1 and K2 respectively. Okay, is written in two steps, and they have equilibrium constant K1 and K2 respectively. Okay, so I will give you an example. For example, let us say we have a reaction N2 plus 2O2 is giving us 2NO2, and let's say the equilibrium constant for this reaction is K, and let us say that this reaction takes place in two steps. The first step is N2 plus O2 is giving us 2NO, and let's say the equilibrium constant for this one is K1, and the second step is 2NO plus O2 gave us 2NO2, and let's say the equilibrium constant is K2, right? So you can see this reaction took place in two steps. This is the first step, this is the second step. If you add these two, you're going to get the OG equation, right? So whenever this happens, you can write the original equilibrium constant is equal to the product of the equilibrium constant of the two steps in which it took place. So K will be equal to K1 into K2. Okay, so in this question they have given us two things. They have given us 2xy is forming x2 plus y2, this is reaction 1, and xy is combining with half of z2 to give us xy z, so this is reaction 2, and we have to get reaction 3 somehow. Okay, so this is our aim. Our aim is to get this reaction, that is half of x2 plus half of y2 plus half of z2 is giving us x, y, z. So let's say this is reaction 3. Okay, so our aim is to get this equation from these two, okay, by doing some addition, subtraction, inverse. Okay, so let us say the first step is step A. So reverse equation 1. Okay, so this is equation 1. Reverse this, so it will become x2 plus y2 giving us 2xy. Okay, so it will become x2 plus y2 giving us 2xy. So let's say this is reaction A. Okay, and we know if a reaction is reversed, the value of equilibrium constant is inversed, right? So K1 is given to us, the equilibrium constant of this reaction is given to us, that is 2.5 into 10 power 5, right? So K1 is 2.5 into 10 to the power 5. So since this reaction is reversed, so the equilibrium constant for this reaction, let us say that is Ka. So Ka will be equal to K1 to the power minus 1, because we reversed reaction 1. So therefore Ka will be equal to 1 by K1, or you can write it as 1 by 2.5 into 10 to the power 5, right? So this is step A. Then multiply equation A that we obtained in A, this equation, by 1 by 2. Okay, so multiply this equation by 1 by 2. So 1 by 2 throughout the equation. So we will get 1 by 2 x2 plus 1 by 2 y2 giving us xy. So let us say this is equation D. Okay, and we know that if a reaction is multiplied by n, the new equilibrium constant is old equilibrium constant to the power n, right? So Kb, that is the equilibrium constant of this reaction, Kb will be equal to the equilibrium constant of old reaction is this one, right? That is Ka. So it will be Ka, and we have multiplied the equation A by 1 by 2. So therefore Kb will be equal to Ka to the power 1 by 2. So Ka to the power 1 by 2, or root of Ka. So this will become square root of 1 by 2.5 into 10 to the power 5, and we can write 2.5 as 25 by 10, So 10 and 10 power 5 is 10 power 4. So this is basically 1 by square root of 25 into 10 to the power 4, which is 1 by 5 into 10 to the power 2, right? So this is the equilibrium constant for this reaction. Okay, now the third step is add equation B and equation 2. So this is the third step. So equation B is half of x2 plus half of y2 is giving us xy. This is what we obtained. Remember, this is equation B, and equation 2 was, remember, this is given to us that xy plus half of z2 is giving us xyz. Okay, so I will write that down. So that is equation B, and equation 2 will be xy plus half of z2 is giving us xy z. That is equation 2. If we add these two equations, we get half of x2 plus half of y2 plus half of z2 giving us x, y, z. And you can see this is nothing but equation 3, right? Equation 3 was our aim. We have written that our aim is half of x2 plus half of y2 plus half of z2 is x, y, z. And we have exactly got that. Half of x2, half of y2 and half of z2 and x, y, z, right? So we can say that, equation 3 can be written in two steps. That is equation B and equation 2. This equation can be written in two steps, equation B and equation 2. When we add them, we get this OG equation, right? So we can say that the equilibrium constant of third reaction is the product of the reactions in which it can be written, or it can be broken down into. So K3 is nothing but Kb into K2, right? We have already discussed in the characteristic of equilibrium constant. So Kb we already know, it is 1 by 5 into 10 to the power 2, and K2 is given to us that K2 is given to us as 5 into 10 to the power minus 3 in the question. So into 5 into 10 to the power minus 3, so this gets cancelled. So it is 10 to the power minus 5. So therefore 10 to the power minus 5 is the answer. Okay, thank you.